Hi everybody, I hope you're doing well and that your studies are going smoothly. Welcome back to biopsychology. It's time to do some revision. Let's crack on. Okay, so we're going to focus on neurons and neurotransmission today. Here are some exam style questions. Do pause the video, have a go, engage as best you can in hopefully some quiet, controlled, timed conditions, ideally. But if you're not quite there yet, that's fine. Feel free to listen along, but it would be good. I would encourage you to try to do it by pausing the video and seeing what you can remember. Then come back and I'll talk through. Okay, final chance to pause. And we're off. Okay, command word is identify, so you just need to state. So the three types of neuron, in reality there are more than three, but in terms of what you're expected to know here, we want motor neurons, sensory neurons and relay neurons, or you might call them interneurons. Okay, for 4 marks, again nice and quick. A is the nucleus, C the dendrites, D is the myelin sheath, B is the axon. Same again here. This is the diagram of the synapse. So part D is actually the synapse or the synaptic gap or synaptic cleft. A looks like to me that's pointing at the vesicle or vesicle, the kind of bubble that contains the neurotransmitters. Where are we? Moving across into the middle, B is the neurotransmitter itself, and C is the receptor or receptor site. Okay, that was a nice easy 11 marks. Okay, so here we have to do a little bit of writing. We are outlining how neurons communicate with each other. Okay, so with each other, so that's telling me about, if you've got 2 neurons, how does that message get across the gap? Okay, so here we want synaptic transmission, and it is only 3 marks. We'll look at a 6 mark later. So all I would say here is that you need to try and get across kind of the beginning, the middle, and the end of the process. So don't write 3 marks of, a 6 marker and stop halfway, because you're not going to get full marks for that, no matter how detailed that is. Okay, so the signal arrives at the end of the presynaptic neuron and stimulates the vesicles. These release neurotransmitter into the synapse, which binds with the receptors, which excites or inhibits the next neuron, allowing the signal to continue. That's plenty for 3 marks. There's more we could say. As I said, we'll look at a 6 mark in a minute. Right, the command word here is distinguish, so the difference between inhibition and excitation. Well, clues in the name here. So one is about inhibiting, one is about exciting, but what does that really mean? So inhibition is where the neurotransmitter binds with a postsynaptic receptor and makes it less likely that that cell is going to fire. Yeah, it inhibits the response. Whereas, there's that comparative language we need. Excitation is where the neurotransmitter binds with the receptor and makes it more likely that the next cell will fire. Yeah? It's not just it makes it fire or doesn't make it fire, because it's about lots of neurotransmitters going on at the same time, and there's lots of inhibition and lots of excitation. We'll come back to that in a bit. But inhibition is making it more, less likely to fire. Excitation is making it more likely to fire. Okay, we want an example. We want to talk about reflex actions. Okay, so nice straightforward example. If you've ever put your hand on, a hot hob, or a hot pan or something, then you know what this is all about. So let's use that. Okay, so in the context of putting your hand on a hot hob, your sensory receptors on the skin, on the fingertips, would perceive the heat, and this would be transmitted via a sensory neuron towards the central nervous system. It would be received by the spinal cord. It may go via a relay neuron, but it would essentially go to the spinal cord and come back via a motor neuron, which would then instruct or send a signal to the muscles relevant to moving your arm away. So that might be muscles in the shoulder, in the wrist, finger, wherever. And therefore you would move your hand away from that hot hob before too much damage was done. Okay, so sensory neurons receive that information from the environment, so the heat there, they send it towards the central nervous system. The central nervous system decides, okay, we need to do something about this. It sends the message back via the motor neurons, which connect to your muscles and make you move. Okay, referring to structure and function here, so what do they look like, how are they made up, as well as what do they do? Distinguish, so another key word there, between motor and sensory neurons. Okay, so we've touched on this a little bit in the previous question actually. So, functionally, one difference is that motor neurons carry information away from the central nervous system, whereas sensory neurons carry information towards the central nervous system. Yeah. Sensory neurons are kind of your input, and motor neurons are kind of your output. In terms of structure, motor neurons look much more like that kind of classic generic neuron, like you can see at the top of the questions there that we did earlier on. They have the cell body, at one end. They have the axon projecting down one direction and terminate in those terminal buttons at the end. So that they look very much like the one you can see on the screen. Whereas sensory neurons have the cell body in the middle of the neuron, and the axon kind of comes off and splits in two different directions. So that could be what you say in terms of structure. The other thing that you could mention, if you felt like you didn't have enough detail, is saying that sensory neurons receive input from the environment, or from, for example, the skin, or from sensory organs, whereas motor neurons connect to muscles as opposed to organs. Okay. Right. Outline the process of synaptic transmission. So we've been through the process basically, so a little bit more depth then. So the action potential arrives at the end of the presynaptic neuron, and it stimulates the vesicles. These release neurotransmitter, and this process is called exocytosis. The neurotransmitter diffuses across the synaptic gap toward the postsynaptic membrane in order to bind with the receptor sites there. Yeah. When it, and this is where we're going to go into a bit more depth, okay, about what happens afterwards. So when the neurotransmitter binds with the receptor, if it's an inhibitory neurotransmitter, it creates an IPSP, an inhibitory postsynaptic potential. Yeah, that's the inhibition we talked about earlier. It's not going to completely switch it off at this point. It's just creating the potential, if you like, for it to turn off. It's making it less likely that it's going to fire. If the neurotransmitter is excitatory, then it creates an EPSP, an excitatory postsynaptic potential. Yeah. All of these inputs, if you like, the IPSPs and the EPSPs, are put together. They're summed, they're added up, not literally like with a calculator, but you know what I mean, in a process called summation. And if the EPSPs outweigh the IPSPs, so if there's more excitation than inhibition, and it's enough to meet the threshold for the cell, then that cell will fire. Yeah. If the IPSPs outweigh the EPSPs, so there's more inhibition and it doesn't meet that threshold, then that cell, that postsynaptic cell, will not fire, and the communication will be stopped. Something else that you could throw in, although we've probably got enough already, is the two different types of summation that you might be aware of. So temporal summation is about all of the EPSPs and IPSPs within a kind of time window, which might only be, milliseconds we're talking about possibly. So that's temporal. Temporal is time, remember. And you've also got spatial summation. So that's about kind of over an area. So it might be over, a whole dendrite, or even over the whole cell. But all of those EPSPs and IPSPs will be kind of added up together across that space. So that was spatial summation. Okay. The last one, outline the role of summation. Okay, so I've put this afterwards. We've pretty much covered what we need, but I've put this afterwards because, in my experience, this tends to throw people a little bit more than just a general, outline synaptic transmission. But we see summation, we need to be talking about IPSPs and EPSPs, we need to be talking about the cell either firing or not firing, we need to be talking about temporal and spatial, if it's specifically on summation for 4 marks as well. Okay. Whereas if it was a general synaptic transmission one, we wouldn't necessarily need to be talking about temporal and spatial summation. Okay. Right. Okay, so it's that time again. Reflect on how that's gone. What did you get right? What did you get wrong? How easy was it? Did you do it within time? Did you have to have a cheeky look up of anything? And what are you going to do next? How is this going to feed back into your future revision and your future practice and your future learning? Okay, cheers everyone. I hope that was useful. Do feel free to ask me a question and I'll get back to you. Good luck with it all. Keep going. You can do this. Bish bash bosh.